Hello everyone and welcome to the third video of making a game even though I have no idea how to. In the last video we had a basic demo of the generation going on, and at the end of this video we're going to have, wait for it, the exact same thing. I know, right? Brilliant! Just kidding, I'm going to implement multiplayer support. I might even add the planet surface if I'm feeling ambitious. So I started out planning what's going to go on the client and what's going to go on the server. There needs to be an identical object structure on the client and the server needs to send over the information in a serialized form to the client. And that means basically I need to have similar code structure between the client and the server, but they don't necessarily hold all of the same data. But some of the data needs to be transferred. As a general rule of thumb, data is generated on the server, then sent over to the client. And wherever possible, the server generates a small amount of data, sends it over to the client, which then extrapolates, which is how the noise works. The server doesn't generate the noise, it sends over the parameters where the client can reproduce that noise without having to send it over to the client. This reduces bandwidth dramatically. Then it was a simple, and I say simple meaning complex, task to get the client to send the request to the server and the server to respond with that request with some data. Now the way I've done it is that the client has to request data before the server sends it. Now this is not good in a very real-time game. This is very bad in a very real-time game because then it's increased latency, and also it means that some things don't get updated as quick as they could be. But it's good for bandwidth because you're only requesting the data you need, and it's also much simpler to implement. I went with ASIO as the network library because it's cross-platform, which is important because I'm developing on Linux and probably, unfortunately, most people are going to be on Windows. And therefore, I want something that's easily cross-platform and I don't need to have a Windows machine to test it on because that's a pain. And it also seems to be fairly well documented, which is good, even though it's quite hard to use. Well, in my opinion, because I'm not very experienced with these things, it took me a while. But eventually I got it working. That was probably like the biggest time consumer of this entire networking thing, was actually getting the library to work successfully. And then it was rather plain sailing actually from there, until I noticed that it was very stuttery. And I don't mean a little bit stuttery, I mean drops to 0 FPS for a second and then back up again. Now, that is because it's loading sectors using the network in the drawing thread. Now, that is very bad, and I knew this would be a problem. I just couldn't be bothered to fix it yet, to be frank. And so, actually, that took me a long time to move to a different thread because things kept going wrong, like some sectors wouldn't load, and also I couldn't figure out how to use mutexes and those things, condition variables, because they were all new to me and I needed to learn that all from scratch. So that took me a while. But eventually I got it working, and I kind of ignored the fact that it just didn't load sectors sometimes, because actually that turned out to be fixed later on when I fixed another issue. Then I decided to implement a bit of an optimization, where I, instead of sending one sector at a time and then expecting one sector at a time back, I sent multiple sectors at once to the server and expected multiple sectors back. It was actually fairly simple, and it did actually help towards the sectors aren't loading, but it didn't fix it altogether. And ironically, I can't actually remember how I fixed the sectors not loading issue. I just know that I did, and it was some stupid problem similar to, I think it was actually similar to, the bug I had before where they weren't generating when it was just a client-only program. And so I fixed that, and because it was a while ago, I'm currently doing this voiceover on July the 2nd. And I probably fixed that bug many weeks ago, back in June, maybe even before. So, yeah, it's taken me a while, let's just say that much. But I did decide to be ambitious, and now I have a planet surface. This is the first test I did of the isometric tile map. You can see here I'm just using noise and not any tiles or anything like that. I was just testing out the maths of isometricness, and it's actually quite simple. I won't explain it here because, I don't know, this isn't Maths channel. But yeah, the only issue with this is because noise is quite slow. Even the fast noise library is quite slow. So drawing this amount of noise is actually quite taxing on the CPU, and I'm only getting a low frame rate here. So it's great that I started with the planet's surface, because that is actually a step towards getting gameplay to work. And getting gameplay to work is a step towards it being an actual game, which is kind of what I want. I still haven't got any gameplay right now. That should actually be mediumly simple to implement, seeing as I've got quite a lot of the framework already going. So the planet's surface was actually kind of easy to do. And don't get me wrong, it was a pain, but the concept was kind of simple. So what I did was I have a tile map, and I decided on isometric, even though ADIAC said it was a bad idea, because I like the look of it and it seemed more fitting for the style. Even though ADIAC says it looks 3D in my 2D game. I just think that doesn't apply. The planet's surface is represented as an array of integers. The integers represent the state of each tile. There are the same number of tiles on the planet's surface as pixels in the planet preview type thing in the star system view. As I wanted to make the planet's surface look like the preview, I decided to go with mostly grayscale textures. This means I can actually use the OLC Pixel Game Engine's decal feature. Decals are like sprites that live in the graphics card, and it's brilliant because they are very fast to draw, almost instantaneous, and they also can be tinted, rotated, scaled. Loads of operations like that, and warped even, can be performed in next to no time at all. It's very, very efficient. Unlike sprites, which take up CPU time, these take up GPU time, which is different from most of the game, which is almost entirely CPU bound, just because of the nature of the game. Graphics isn't the big thing here, it's the CPU processing. So I made some of the textures grayscale. Some of them will not be grayscale because they will not depend on which biome, as I'm calling it, they are in. Some of them will just be like a building is not going to be tinted green if it's in grass, right? That's just common sense. But a tree might change colour depending on the environment. Say it's sort of, say the grass and stuff is brown on the ground, maybe because it's winter. The trees will probably not have any leaves, which will make them pretty brown. So I just tint a grayscale tree and a grayscale ground to the colour that is decided by the same function that decides the colour of a pixel in the planet preview. Now, that might be a bit complicated, but I find it quite a nice, elegant solution. It also means that it's very flexible, because I don't have to have sprites for different colours, and sprites can be changed on the fly, and it also gives quite a degree of control just by editing the sprite of what it looks like. What you've been seeing in this time lapse is pretty much just Elikano and me. Well, I was coding and Elikano was doing some textures because he's good at stuff like that, and I was basically just trying out some stuff and polishing all the planet surface graphics. And something I'm particularly pleased with is where the sea or the water is actually slightly lower down, or actually technically it's just further down the screen in isometric space than the land, which really gives it a feel of depth. And I then modified the ground tile to have a sort of edge so it looks nice. And hopefully I could actually even use that to make hills and different heights in the land at some point as well, which I think now that there's a bit of depth there, I can't just stop there. I've got to go the full 9 yards, if you see what I mean. Anyway, that'll probably do it for now, since there's been quite a lot of content being added lately, and it's been taking me a while because I've had to learn quite a lot of new concepts from scratch. But hopefully I'll be back next time, hopefully a bit quicker, maybe even with some gameplay going on, because I'd really like to get to that stage where you can actually play it as a game. Maybe not fully play it as a game, but interact with the map. So firstly I'll have to do saving, secondly I'll have to do communication from the client to the server rather than from the server to the client. Then I will have to implement a system in the client for actually modifying things and sending that to the server through that communication protocol, and then I've got to make a way in the server to save that information. And I might even add some metadata bytes to the planet's surface and yada yada yada. Implementation details. Anyway, like and subscribe, and bye!